So I will continue the lesson. Last time I finished until this part. If you still remember the operator precedence, it means you need to know what is the first and then what is the next, and so on. So you already know that if we have, for example, 3 multiplied by 2 plus 5 divided by 2. So if you have like this kind of formula, you know that multiply will be first, and then division will be next, and then plus will be the last. Because we follow this operator precedence. So plus and minus, unary plus and minus, it means this is the minus or plus for the number. For example, whether it is positive or negative number. And then this is exponent. And then this is not, which is to find the negation. And then this is the mathematical operators, multiplication, division, integer division, remainder. This is binary addition. So for example, 3 plus 2 is 5. 5 minus 3, it is 2. So this is the binary addition. And then it will be followed by the comparison. Less than, equal, greater than, equal. And then equality. Equal, not equal. And then and, or, and this is the last one. Okay. So this is the precedence or the order. So as I mentioned before, the parenthesis is evaluated first. The expression in the parenthesis. So if we have 5 plus 2 multiplied by 3, then this will be done first, and then we will do this next. Parenthesis can be nested. So it means you can have 5 plus 2 and then divided by 3 minus 1, something like this. So you can have nested. So when evaluating an expression without parenthesis, the operators are applied according to the precedence rule and the associativity rule. So this precedence rule and the associativity rule is from this one. Okay. So this is the first, second, third, and so on. If the operators with the same precedence are next to each other, then their associativity determines the order of evaluation. So most probably, when we do with this order, it is from left to right. So the computer knows from left to the right. All binary operators except assignment operators are left associative. Left associative means, yeah, it is from left to the right. So operator associativity means when two operators with the same precedence are evaluated, the associativity of the operators determines the order of evaluation. As I mentioned, the associativity, yeah, one of the precedence rule is from left to the right. All binary operators except assignment operators are left associative, like this one, because all of them are in the same precedence rule. So we will check from left to the right. So this one, maybe, yeah, this is equivalent, left, and then this one, and then finally this one. Assignment operators are right associative. It means if you have the equal sign, you have equal sign, you have equal sign, so it is always right associative. Okay? Right associative. Right associative. It means that we will follow the rules from the right to the left. Let's say this one, I have C equals to 5. Okay? And then B is plus equal C. Then B will be C plus B will be B plus C. And then C is 5. And then what about A? A will be equals to B plus C. Okay, so this is the meaning by right associative. Okay, now we have problem about palindrome number. What is palindrome number? Write a program that prompts the user to enter a 3-digit integer. Okay, and determines whether it is a palindrome number. A number is a palindrome if it reads the same from the right to the left and from left to right. So, for example, 1 to 1, it is palindrome because you can read 1 and then 2 and then 1. 131 is also palindrome. 112 is not palindrome. Okay. The easy way to determine this one, because we have only 3, it means the first and the last should be the same. But let's say if you have 1, 2, 3, 1, is it palindrome? No. Okay. If you have 1, 3, 2, 1, is it palindrome? No. Okay. If you have 1, 5, 6, 5, 1, is it palindrome? Yes. Okay. So in the common sense, it should have the same order when we read from the left to right or right to left. For the simple problem, let's use the 3-digit number. Okay, now let's just use 3-digit. Maybe after next week, yeah, we will learn how to determine the palindrome number more than 3 digits. Oh, sorry, I guess I wrote the wrong keyword name. So I give the solution. Okay, let's see the solution. I will make the palindrome. I will make a new Python file, palindrome. So I'm going to enter a 3-digit integer. So let big N equals to number. So the big N will be the same with the number that the user entered. So I will do the division integer. What does it mean by this one? Division integer. Let's say I have the number 1 to 1. What is 1 to 1 divided 100? Is 1. Okay. And what about this? 1 to 1 remainder 100? 21. Okay. And then we will save this number into N1. We will save this number into nothing. Okay, we don't put any variable for this one. And then we can have n2. N2 is num divided by 10. 1 to 1 divided by 10. What's it? It is 12. Okay, and it will be saved in the N2. And then we have num remainder 10. Oh, sorry, this one remainder equal 10. So it means 21 will be saved into the variable num. And then we have the num remainder 10. So num is 21 remainder by 10. Then it will be 21 remainder 10. The remaining value will be 1. So plus n3 equals to num. Then n3 equals to 1. Because we only have 3 numbers, so we will just check the n1 and the n3. If n1 equals n3, then it is palindrome. If not, then it is not palindrome. Okay. So if you run this, enter 3 digits. Let's say 151. So it is palindrome because the first digit equals to the last digit. Okay. Okay. So there is one example given in the book. We need to calculate test whether a point is inside a circle. So the program prompts the user to enter the center of a circle, the radius, and a point. And then you need to check whether that point is inside the circle or the point is outside the circle. So how can you make the code? We can use the distance in order to check whether the x1 and y1, where is the location of x2 and y2, and then we can check the distance. If the distance is higher than the radius, then it is outside. If the distance is lower than the radius, then it is inside. Okay. I give the solution. You can go to the class. There is one file, example 4.36. Wait, I forgot whether it is the correct answer or not. Let's see. Okay, you can download this one, and then you can go to the Python environment. So in the Python environment, in the PyCharm, you can look at this project. Okay. In this project, you can do right click, and then you can open the file. You can open the files, or you can open the project in the Explorer, or you can open the project in the directory path, or you can open the project in the terminal. So if you open the project in the Explorer, then you will see this page. So you can access the Python project. Let's say I want to put the files in the chapter 03. Then I can paste the file here. So you can see now the file from the e-class will be in this section. Okay. And after you have the files in the Explorer, so you can refresh. Okay. You can refresh this part. If you refresh this, where is refresh? Or you can reload from this. You can see there is one file, example 4.36. Okay. Then there is a Python code that you can run in your PyCharm environment. So in the beginning of the class, I teach you how to use the turtle. Okay. So we can also use the turtle in PyCharm. And this is one example. We can use the random value, and then we can use the turtle. So I can determine, for now, I can determine the x1 and y1. And then for the x2 and y2, it will be random. And we can ask the turtle to create the circle. And after the turtle create the circle, the turtle will draw the point. After the turtle draw the point, then the turtle will draw the status. The status will be whether the point is inside the circle or the point is outside the circle. See. There will be question. Enter the center of circle. Maybe let me give 0.0. Enter the radius of the circle. Let's say 10. So, okay, it's too small. So you can make it larger. If you run, enter the circle, maybe 0, 0. Enter the radius of the circle, maybe let's say 300. Then you can see that the turtle is now drawing a circle. And okay, based on the random value, this is the location of the point, and the point is inside the circle. Okay. Okay, so you can take a look on the turtle. Maybe you can play something with this turtle code. Okay. So the first section is about the Boolean. Okay, you know how to address the true and false. And we have the if, else. And then we learn about the nested if and some logical operators like and, or, not, and so on. Okay. So any question about this conditional? So I will continue to the next section, which is about the repetition. Okay, since you already familiar with Python and PyCharm until now, I do not give any code in the PowerPoint. You can go to the e-class in the material, in the repetition, you will see a zip file. See, it's AP, so it means chapter 04. You can download this chapter folder.zip, and then you can put that chapter, maybe in this case, yeah, I put here, and then you can upchuk toolkit. Okay, you can extract the file from the zip. After you extract the files, you will see there is one folder, chap 04. Inside this chap 04, it contains many Python files. Okay, so instead I give you the code one by one in the PowerPoint, I give this code, so you can just directly copy and paste this code into your PyCharm. Or if you don't want to copy one by one, okay, you can go to this project. You can open the project again in Explorer. So once you already have this project, you can open this Python project and you can paste the folder chap 04 in this project. So once you paste this one, you will see all the codes that I already give to you. It will be in this directory. So now you will have this directory for the chapter 04. Okay, please make sure if you want to know the code, you can do this one. Okay, I will start the repetition section. So the contents of this PowerPoint will be about what is the repetition, what is nested loops, and loop with some conditional alternatives. So repetition or loops. The motivation of this is actually about how if you want to print something more than 10 times or more than 100 times or more than 1000 times. For example, I want to print string like this one, programming is fun, for 100 times. Then what should I do? Are you going to print programming is fun? Programming is fun for 100 times? So if you want to do this one, it's very tedious or it takes a lot of time. So you copy and paste, copy and paste, copy and paste for 100 times. Instead of doing this one, yeah, you can use loop. So the simple loop is using the while loop. So this is the code. The variable count will start from 0. While count is less than 100, then print programming is fun. Count will be added by 1. So it will check in. Is count less than 100? Yes. Then print again programming is fun. Is count less than 100? Yes. Then again print programming is fun until count equals to 100. So if I put this one in the chapter 4, I make Python file, let's say practice. So I have this code, and then let's say I will run. So you will see the result is Python programming is fun for 100. You can calculate by yourself. So if you want to make it small, 10, for example, then you will have 10 times of the line. So using this kind of while or using the loop, it will be easier for you to repeat something. So the flowchart will be something like this one. We have the condition. If the condition is true, then we will do something. Then we will check again the condition. If the condition is still true, then we will do again the statement. So we will do the statement until the condition becomes false. So in this case, count equals to 0. And then count is less than 100. Yes. So we will print programming is fun. Count will be added by 1. So count now becomes 1. It will check again to the condition. 1 is less than 100. Yes. Then it goes to this statement and so on. Until the condition false, then we will go to the next statement. You can see from this one, count equals to 0. This is the initialize the variable count. And then we want to check count less than 2. Because 0 is less than 2, it is true. So we will print welcome. Oh, sorry, programming is fun. And then we will add the count by 1, increase count by 1, and count is 1. 1 is less than 2. Yes, it is still true, since count is 1. So print again, programming is fun. And then increase the count by 1. Now count equals to 2. Count less than 2? No, because count is 2. Because it is false, then we go out from this statement. So when we do the while loop, we call this is a condition control loop. There is a condition. So in order for a loop to stop executing, something has to happen inside the loop to make the condition false. So because you know that when we do this one, something should happen in order to make it false. If there is no false, then we cannot stop. So when we do the iteration, it means one execution of the body of a loop. While loop is known as a pre-test loop. Pre-test means we have the condition before doing the loop. We call pre. Pre means before. So like this one. Before we do this statement, there is a test condition. This we call a pre-test. Test condition before performing an iteration. It will never execute if the condition is false to start with. And it requires performing some step prior to the loop. So for example, this kind of loop will be infinite loops. What does it mean by infinite? Okay, never ending loop. So loop must contain within themselves a way to terminate. So there should be something to finish. There should be something to end the loop. Something inside a while loop must eventually make the condition false. So infinite loop means loop that does not have a way of stopping. For example, this one will be error, right? I equals to 1. While I is higher than 1 or 0, is it true? Yes. So we will print I. And I will be added by 1. Then I becomes 2. 2 is higher than 0? Yes. We will print I. And then I will be added by 1. So I becomes 3. 3 is higher than 0? Yes. I will become higher and higher. Then when will it stop? Never. So this kind of while is wrong. It will give you infinite loop. This one. J equals to 1. While true. So true is the condition. Okay. I want to print J. J equals to J plus 1. So J will be 2. While condition is true. Okay. Print J. So it will print 2. J will be added by 1. So it becomes 3. It will always be true. So when it becomes false? Never. So this kind of while is also wrong. It will make you the infinite loop. So it means the repeat until program is interrupted. So occurs when programmer forgets to include stopping code in the loop. So let's see. I will make this one in Python, in PyCharm. Okay. So if it happens to you, how can you stop it? Okay, let me run. Okay, how can you stop this one? Yeah. Break. You can break in PyCharm with this symbol. Okay. There is a symbol here. Oh, sorry. This one. It is to stop. Okay. So if you don't stop, it will keep showing like this one, and it will make your computer heavy. So you need to stop it because it is never ending loop. Okay, so there is one problem that we can solve. If you still remember, last time we tried to make quiz, okay, subtraction quiz. So the math subtraction learning tool program generates just one question for each run. So I would like to use loop to generate questions repeatedly. So in the last chapter, we make quiz only one time, finish. But how if I want to make, for example, 5 questions, and then I will give the report to the student. How many questions that the student can answer? How many problems that the student answer correctly? Okay, so how can we give that kind of answer? So go to the repeat subtraction quiz. Okay, so there's one file here, repeat subtraction quiz. Oh, maybe this is another example. Okay, this is another example. So I have n1, I have n2, it is random integer. If the n1 is less than n2, swap. Okay, so I guess you already know this one. And then I will ask the student about the subtraction. So if the answer is not correct, we will give the same question again to the student. So what is 9 minus 1? Maybe 7. Wrong. Again. What is 9 minus 1? 6. Wrong. Again. What is 9 minus 1? 2. Wrong. Again. Until you give the correct answer, which is 8. Then it stops. Okay. So how you can make this code? You will make with while, and then while the answer is not the same with the n1 minus n2. So if it is not the same, then let's ask again to the student. So we will do this loop until it is correct, and if it is correct, then we finish the problem. So there's another program, guessing numbers. Write a program that randomly generates an integer between 0 and 100. And then the program prompts the user to enter number continuously until the number matches the randomly generated number. For each user input, the program tells the user whether the input is too low or too high. So the user can choose the next input independently. So guessing number means you need to guess what is the number generated by random function. So let's see with this example. With this example, I will generate a random number and you can guess the number. If the number is correct, then yes, the number is that number. But if the number is higher than the random number, you will show your guess is too high. But if the number is too low, then you will show your guess is too low. So guess a magic number between 0 and 100. Let's say I guess 70. Your guess is too high. Finish. But I do not know whether the number is really high or low and what is the number. So you can use loop. What is loop here? I will do several times until I know the numbers. So let me guess. 70. Your guess is too low. Then, okay, I can increase the number. 90. Your guess is too low. Okay, I guess 95. Yes, the number is 95. So we can make the repetition until we know the numbers. In this case, we are just using while. If the guess is not equal to the number, repeat the condition until the condition is correct and the guess equals to number, then we finish the loop. Okay. Okay, I guess it is the time to finish. Any questions?